Good evening, friends. I welcome you all for this webinar, and it's indeed my pleasure to be here with you for this webinar. I am getting connected with Tiscon for this webinar for the first time, and before I go to discuss today's topic, that is the reinforcement guide for home construction, I would like to give my brief introduction. My name is S.B. Kulkarni, and I have done my civil engineering from VJTI Mumbai way back in 1980, and after that I have worked with construction field for more than 10 years, where I was involved in construction of residential industrial buildings. As a site engineer I started my career, and then somewhere in 91 I finished my management master's degree, and then I joined cement industry in the marketing division. I joined Aditya Birla Group, and currently this group is known as Ultratech Cement. But way back when I joined, that was Indian Rayons, but today it is Ultratech Cement, Aditya Birla Group. And almost I worked in the cement industry for more than 25 years, and 2 years back I retired from Ultratech Cement as a All India Technical Head and Vice President Technical Services in Key Accounts Department. And since then I am a freelance consultant, and currently I am working as a principal technical consultant with Criso India Private Limited. They are into basically construction chemical manufacturing, and I wish to thank Tiscon for this initiative which they have taken, through which they want to share the knowledge amongst the young engineers, professionals, architects, and all those who are connected with the construction industry. This is the 16th webinar which is happening here, and we have to thank the technology today, because of which today we are connected on pan-India basis. I am sitting in Mumbai, Andheri, and I am talking to you all, my friends who are perhaps sitting at the every nook and corner of the India. And I'm very happy to know that today more than 1500 uh, engineers have registered, and plus so many who have not registered, but through the dealers of the Tiscon, this program is being seen by so many professionals in the country. It's indeed an opportunity for all of us to be together for next 45 minutes. The presentation would continue for 45 minutes, and after that, at the end of the presentation, we will be taking up some questions. You all are free to send your questions during the presentation also, but the question answers session would be taken up only after the presentation is over, and maybe we will spend some 10-15 minutes in the end for the question answer session. So we take up the presentation today. The topic is reinforcement guide for home construction. The presentation outline would be something like this. First we will discuss about the steel industry, then what is this reinforcement, why reinforcement is required, little history about the steel industry, then what are the requirements of steel reinforcement, what are the Indian standard specifications which are required for steel to be used in the construction industry, what IS 456-2000 has to say about the steel. Then we want to also cover few steel constituents which improve the quality of the steel, or there could be some disadvantages also because of some particular chemicals. We will see that. We will discuss about importance of cover to be provided to the reinforcement, why it is required. We will also cover the impact of corrosion on the construction, and we will through few interesting slides, we will see what are the practical examples of do's and don'ts when it comes to the reinforcement. And finally, we will conclude, and then after that we will be taking the question answer sessions. So we first understand what is reinforcing steel. Reinforcing steel is an alloy of iron and carbon basically, and it is the most important ferrous metal in building construction. It is relatively, this iron is relatively abundant in the earth crust. It is only next to the aluminium. And iron undergoes a change of crystal structure at red heat, and which assists in many production processes and leads to metallurgical advantages. For example, in cement industry, uh, we manufacture clinker. So iron ore is one of the raw materials which is used, which provides a very good flux, and because of that the clinkerization process highly improves. It assists. It's like a catalyst in the cement manufacturing process. We will see how steel industry has grown in India first. In 1947, when India got independence, the manufacturing capacity on pan-India basis was only 1 million ton per annum. And if you talk about recent development, during 2014 to 16, India was third largest producer of sponge iron, and total steel produced in India was around 101 million tons, and we had more than 50 plants in India then. And as per the latest current information, in 2018, India is second largest producer of steel, and production figure is 106.5 million ton. This is the I think interesting statistics we should have at the back of the mind. Who are the major steel manufacturers in India? Of course, Tata Steel is there, Tiscon is there. They are one of the leading manufacturers. Apart from that, Steel Authority of India Limited is there. Then Bhushan Steel, JSW Steel, Vizag Steel, SR Steel, Ispat Industries, and so many other small, and medium-sized players are there in India. I would not like to cover all of them, but these are a few major players who are playing important role in manufacture of steel. What are the requirements for reinforcement steel? Number one, steel should have high yield strength or proof strength. Number two, steel must be ductile enough to permit bending as well as to guard against the brittle failure. We cannot accept brittle failure in steel. It should be ductile, and steel should be weldable to facilitate joining. Many times this reinforcement is to be welded also. Many consultants recommend in particular situation. Normally we tie the steel with the bending wire, but then in many situations welding is also recommended by a few consultants. So steel should be weldable. What are the IS specifications of steel? Indian standard specification for high strength deform bars, as per IS 1786, recognizes three strength grades. For example, FE 415, FE 500, and FE 550. These are the three grades recognized by the Indian standard, and the figure following the symbol Fe. Fe means for iron, we know iron is known as Fe, and the figure which is following the symbol Fe indicates the specified minimum proof stress or yield stress in Newton per square millimeter. In cement industry, we talk about grades of the cement. There are three grades: 33 grade, 43 grade, 53 grade. So these figures 33, 43, 53, they indicate the compressive strength of the cement mortar cube in Newton per millimeter square. On the similar line here also, it is the proof stress that is indicated by this figure 415, 500 and 550. Internationally, if we compare the standard codes, British standard specification has uh, two grades of steel, grade 250 and the standard specification, whereas ASTM, that is American standard A615M of 1988, classify reinforcing steel into three grades, namely grade 300, grade 400 and grade 550. What are the requirements as per IS 456-2000? As per IS 456-2000, the reinforcement in concrete shall be any of the following four categories. So BIS recommends that there are four categories and any one of the four could be used in the construction. Number one is mild steel, conforming to IS 432, high strength deformed bars, conforming to IS 1786-1985, hard drawn steel wire fabric, conforming to IS 1566, and structural steel conforming to grade A of IS 2062. So these are the four categories. All these four categories can be used for construction. Now we will discuss something about the constituents of the steel and its effects. There are almost more than, I can say, 10 to 12 constituents which are there in the steel, but we have to consider two important properties which these constituents should give to the steel. Number one is the strength. This constituent should give more strength to the steel, and number two, what is more important from the durability of the construction is the corrosion of the steel, and the constituent should give protection against corrosion. If these two properties are covered up, I think we have practically done more than 90%. So carbon, for example, increases strength and hardness. Then phosphorus increases strength and corrosion resistance. Silicon, it increases strength and corrosion resistance. Then vanadium increases corrosion resistance. Chromium, for example, it increases hardness and corrosion resistance. You must be knowing that stainless steel contains chromium and nickel. And nickel also increases strength, toughness and corrosion resistance. There are many other constituents which we will not touch upon them. Maybe when we get some more time, maybe in the next webinar, we can talk on that. Now the question comes, why we have to use reinforcement in the construction? In the reinforced concrete construction, you all know that RCC is a composite section subject to bending moments. When RCC member, whether it is slab, beam, when it undergoes bending, the top portion, the top fiber of the concrete undergoes compression and the bottom fiber undergoes tension. So concrete is very good in taking compression. You all know that, you civil engineers particularly, you all know that concrete is very good in taking compressive forces, whereas it is very weak in taking tensile stresses. Whereas steel is, exhibiting totally opposite character. It is very good in tension, but it is very weak in compression. So when we use both these materials together, it is understood that concrete will resist all the compressive forces and all the tensile forces would be resisted by the steel. So this composite section of concrete and steel put together will resist both compressive and tensile forces, and that is why we require steel to take care of the tensile forces created by the bending moment because of the loading. So I think that clearly explains why we require steel reinforcement in RCC construction. Placing of reinforcement is very important. it plays very important role. Steel may be very good in taking tensile forces, but if you don't place it at the right place in the concrete section, the entire exercise would be futile. It would be of no use. So what kind of precautions we should take? Number one, steel reinforcement should be placed exactly as per the RCC drawings. Structural consultants, they provide us the RCC drawing, steel reinforcement placement drawing. So the site engineers, they have to be, extra cautious to see that the steel is placed exactly as per the RCC drawing. Exactly as per RCC drawing means what? Means the steel required at the bottom of the section for taking compressive forces has to be placed in bottom only, and the steel that is required for resisting negative moment has to be placed at the top. And what is more important is that the bottom steel should remain at bottom throughout the concreting process, and the top steel required to resist the negative moment should remain at the top of the section throughout in the process till the concreting is completed. Then provision of steel chairs is a must for retaining top steel in the top position. If we don't provide chairs in the typical, this shape with two small legs, the steel would touch the bottom steel and the negative moment area would be exposed and you will get a lot of cracks there. Then steel bars should be tied firmly with the binding wire. You can't let the steel bars, go loose. They have to be firmly tied in the position at the desired spacing, specified by the structural engineer. For example, if 10 bars are placed at say 150 center to center, you have to ensure by tying them perfectly at 150 center to center. You can't, allow these bars to displace. So the displacement of the bars is not allowed. Then you have to use planks on the steel bars when personnel are going to move. People are going to move while the concreting process is happening on the slabs or whatever. At that time, you should not allow people to directly walk on the steel. There should be, wooden planks placed on the steel bars so that the bars are not damaged and people are also not getting injured. Then the concrete cover blocks should be provided as per the drawing. As per the drawing means if drawing says that you have to provide 20 cover, 25 cover, 40 cover or 75 cover, depending upon the exposure condition in which you are working, that cover block has to be provided as per the drawing, and lap should be provided as per the norms. No bar can be available in a continuous big length, so you have to join the bars using the binding wire, and the development length has to be properly provided, whether it is in bending or in compression. Accordingly, you have to provide the laps as per the norms, standard norms. Then bunching of the bars should be avoided to allow concrete to pass through the RCC sections like columns and beams. If the bars are placed very closely, how concrete would pass through that? And if concrete is not surrounding the steel bar, then it is exposed because of the honeycombs provided. It is exposed to the weather and steel would undergo corrosion at a faster rate. These days, the current practice is to get rid of these overlaps, particularly, in the columns, where huge number of reinforcement bars are provided and there is hardly any space for the concrete to pass through. Under such situation, if laps are provided, these overlaps would occupy further 20-25% space in that column, and it would be very difficult to place the concrete. Under such situation, in the current practice is to use couplers. These couplers, they join two bars together, and this coupler is not a very big one. It's hardly 2 to 3 inch long piece which is threaded from inside, and the bar is also threaded from inside, and the bar is connected through the couplers, and that saves a lot of steel quantity. It not only saves the steel quantity, because just imagine, for in bending you have to provide roughly 60 to 65 times the diameter of the bar. That is the lap length you have to provide. And imagine, in a huge project there will be lakhs and lakhs of laps to be provided, and how much steel we are wasting. And if we provide the couplers, we will not only save the steel that is wasted in the laps, but also we are using couplers which allows us to freely place the concrete in the section without any segregation. So that is very important. Steel reinforcement has to be stored properly. You cannot allow it to be stored in haphazard manner. Why? Because corrosion is a cancer to the steel. What cancer is to the human being, corrosion is to the steel. So we have to protect the steel from corrosion, and corrosion will happen when steel comes in contact with oxygen and water. When steel, oxygen and water, they come together, corrosion will happen. So we have to protect the steel. So we have to store it in a proper shade, wherein we have to protect it from rains, and also we have to see that uh, steel is protected from the oil spillage, because the moment steel is coated with oil, it cannot have the proper bond with the concrete, and the load transfer will not happen properly. So steel which is protected in the shades should be covered with plastic sheets, so that it is not exposed to the humidity from the air. This humidity again will lead to the corrosion. It should be stored away from the source of the water. The steel should be easily accessible to the site. So you cannot have a steel yard which is some half kilometer away from your site. So it has to be in a nearby vicinity. Then it should be stored diameter wise separately in steel yard. You can't mess up different diameter bars together. You can't mix them up. So if say 6 bar, 10 bar, 12 bar, 16 bar, 20 bar, 25 bar, 32 bar, 40 dia bar, all these bars, they have to be stored separately in the steel yard, and there should be separate space for the scrap. Correct? Because when you cut the bars and use it for reinforcing purpose, you are bound to generate some scrap. So the scrap should be not scattered on the site haphazardly. It should be stored properly, and the separate space has to be designated for storing the scrap, so that it can be disposed of conveniently. Now we are coming to the typical cover blocks which are recommended for steel reinforcement. You can see these are the uh, plastic cover bars of different shapes. The round one what you see here is for the columns, this one is for the uh, beams, and like that. It earlier, when I started my career way back, in those days it was very common to use cement mortar cover blocks, which were locally manufactured at the site. And actually these mortar cover blocks are not recommended, because they are, number one, they are porous. So they kind of they provide kind of a gateway for ingress of humidity and moisture inside the RCC structure. So these site made uh, mortar cover blocks, they should not be used for uh, providing the cover to the reinforcement. What you can see here now, this is a typical cover reinforcement uh, which is recommended. You can see these concrete cover blocks, so neatly finished, smooth, and highly impermeable. uh, these blocks are made with high strength mortar, and these are recommended. You can see this small saddle also, which is provided, on which this bar rests, and the base is broader as compared to the top, so it gives a kind of a stability. These cover blocks, they don't move from the place where they are placed. But you can also see here the steel bars are corroded. It means this steel reinforcement was not stored properly at site. It has already caught some rust. So this should not happen. In the next slide, you will see uh, the effect of corrosion. If the original bar is having, say, a volume of, say, 1 unit, the corrosion products like this FeO, Fe3O4, etc., etc., and finally the corrosion product is FeOH thrice 3H2O. So you can see the steel gets expanded to 6.5 times. So in layman's term, I can say a 10 bar, when it is fully corroded, will occupy a volume of 65 millimeter roughly. So to that extent, the corroded product, the corrosion product will occupy larger volume. Imagine what will happen if the steel bar, which is inside the concrete section, if this starts swelling inside the RCC member, what kind of internal stresses it will generate. And as a result of corrosion, finally the cover which is provided, which is supposed to protect the steel reinforcement, it is literally pushed out and steel is totally exposed to the atmosphere. So we have to provide proper quality of cover blocks so that steel is protected from the corrosion. You can see in this slide, this is a very good example of delamination of concrete due to bad placement of steel, number one. Number two, the cover blocks were not perhaps provided properly. The cover was not provided as per the drawing. You can see here, there is hardly any cover provided to the steel. Steel is directly exposed, it is corroded, and it has thrown away even the plaster that has been put on the slab. You can see one more example where the steel was not protected properly. This is typical, a marine construction where as per the today's IS 456 norm, we are supposed to provide 75 millimeter cover for the steel, because it is coming under extremely severe exposure condition as far as durability is concerned. But you can see here, this is some old construction. They haven't provided more than 20-25 cover to this, and see the result. The steel is fully corroded, concrete is also practically corroded, and God only knows what is going to happen to the structure. If you go to interiors in small towns, it is very common that they will put some chip of the stone as a cover block, which has no stability. When people move on the the steel bars while concrete is being placed, this will just get displaced and the steel will directly come in contact with the steel plate, the steel shuttering plate which is down there. So this concrete will be with zero cover practically moment this get displaced. And you can also see here that at the junction of these two bars there is no binding wire, no binding at all. The bar is just placed above the bottom bar. This is not allowed. This should not be done, because if you don't tie the bar, it will get displaced, and the steel will not be placed exactly at the desired center to center distance, which structural engineer has recommended. You can see here the bar is displaced because the binding wires, uh, I mean, the steel bars are not tied properly using the binding wires, and because of the movement of the people on the slab, the bars have got displaced. You can see here the bars are perhaps at 100 millimeter center to center. At this place it is more than say 200 millimeter center to center, because it has got displaced. This is not allowed, this is not recommended. Then you can see here there is a negative reinforcement provided on this beam portion, and there are no chairs provided. Where this red arrow you can see, there are no chairs provided, and this top reinforcement, which is supposed to be at top throughout the concreting process, how it is going to remain at top when there are no supporting chairs which are provided? So I am 100% sure that when the concrete is going to be finished, in this case, the steel, top steel, which is supposed to remain just at 15 mm distance from the top of the slab, this is going to be pushed inside the concrete, and it will be practically at the neutral axis. So there will be no steel available at the top to resist the negative moment, and because of that bending moment, negative bending moment, this entire say 1 meter on either side of the beam, this portion will develop a lot of cracks because there is no steel available at the right place. The steel is there, but it has got displaced. That is not allowed. Then you can see here that the cover blocks are distantly provided. I mean, you have provided good quality cover block here, you can see here, but it's practically 1 meter away from each other. What is the use? When people walk on the top of this, you can see where that red arrow is, there is no cover block at all. At every 2 feet distance, there should be one cover block. I mean, that is a thumb rule. At roughly, 2 feet distance, you should provide one cover block so that, the steel is placed firmly in the position, and nowhere you will lose the desired cover which is supposed to be provided as per the structural engineer's drawing. Here you can see these column bars are there. You can see this red arrow. These column bars, they are bunched together, and there is no ring provided for these column bars. This is not allowed. For at least 1 meter length, you should provide the rings around these bars as per the drawing, so that when the slab construction is over, when the column construction is taken up, that time these bars are not displaced, because once the concreting is done, it is very difficult to move these bars, and if you move the bars, you are damaging the slab below. So provision of ring is very important. Now what we are discussing is some do's and don'ts, and we are seeing some practical slides wherein I have taken these slides from the site where some bad construction practices have been followed. At some places, some good construction practices have been followed. So I have tried to capture all this together. See, here also you can see there is no provision of cover blocks and chairs. You can see these bars are practically touching the shuttering steel. Under such situation, the durability of the structure is reduced at least by 30 to 40%. If this building is supposed to be there for 75-80 years, in 30-35 years only you will start getting cracks, leakages, and the life of the structure is very drastically reduced. You can see in both the slides here, there are no cover blocks and no supporting chairs provided for the negative moment bars. Now we again come back to IS 456. There are 5 exposure conditions starting from mild, moderate, severe, very severe, and extreme. And IS 456 recommends minimum nominal cover to the reinforcement as 20 mm for the mild exposure condition and 75 mm for the extreme exposure condition. This exposure condition is connected to the durability, and this IS 456 2000 is heavily banking upon the durability. It has been revised keeping in mind the requirements of the durability in different exposure conditions. And this cover plays very important role, because at the end of the day, if the steel is not protected by giving proper cover, who is going to share the load? Concrete will only take care of the compression, but what about the tensile forces? If steel is going to be there intact inside the structure, then only the composite section is going to work and resist the forces. You can see here one very good example. See how much congestion of the steel reinforcement is there in the columns. In this kind of situation, you can imagine how concrete is going to pass through. If you are going to place the concrete from the top, will it reach the bottom or it will get stuck in between? The answer is yes. In this situation, it is very much possible that the concrete will get stuck. The normal concrete will get stuck in between only. It may not reach at the bottom only. So what is the solution? Solution is perhaps you have to use self-compacting concrete. I was talking to you about the couplers. So that what you have seen in the last slide can be corrected by using the couplers. Perhaps they had used a lot of laps for the column bars. That is why you could see that there is no space left. But here there are no laps provided. These couplers are connecting. You can see these roughly 2.5, 3 inch length couplers. This is the length of the coupler, and you can see here these couplers are connecting two bars directly, and there is no lap. So you can see the space clearly, roughly 2.5 inch space is there. So concrete can very freely now pass through these two bars, and this is going to add to the durability. In this, you can see where that red arrow is going. There is no space between two bars. These four bars, they are practically touching each other. There is hardly half-inch gap between these bars. Imagine how concrete is going to pass through. So this is not allowed. You have to provide, at least 2 inch space between the bars, and then only concrete can pass through. In this picture, you can see two things. One is incorrect spacing of reinforcement. This red arrow at the bottom, you can see on the right side of the arrow, the bars are placed roughly at 200 millimeter center to center, and here one bar is missing. Practically this spacing has gone to 400 millimeter, and concreting is going on. It's not that this has been pointed out and there is no chance of correction. Already you can see the concreting is in full swing, and here in the center you can see another red arrow. Here they have not provided enough length of the bars for the column. When the next floor is going to be constructed, when this column is to be constructed, there is hardly any lap length available for these column bars. So in this case, the load transfer will not happen, as per the design, because if the lap length is whatever 40 times diameter, in compression we normally provide, that is the lap length. But I don't think these are the 20 mm bars, and what you require is roughly 800 mm lap length, and this is not 800 mm. All these bars are less than 600 millimeter. So this is not acceptable. This should not be done. Now here you see this engineer, this red arrow, what I have shown, engineer or supervisor, whoever is he is standing on the steel bars, and this is supposed to be a cantilevering portion going on the left side, and you can see the negative moment bars, which are these bent up bars which are gone, and he's standing on the top of that, and these bars are touching the bottom bars practically. This is not acceptable. Again here the proper chairs are not provided, and concreting is going on. So we have come to the end of my presentation. I have done through my presentation, and I would like to conclude now. And in conclusion, I would like to say that the reinforcement steel forms an inseparable and inherently important part of the structure. So we have to take care of the reinforcement in terms of the placement. We have to properly select the reinforcement bars. We have to do proper placement. We have to correctly use the correct use of steel. Definitely will ensure healthy and long life and durability of the structure. Then standard procedure for placement of steel as per the drawing is very important. And if you want very high durability for the structure, protection of the steel, placement of the steel properly, providing proper covers, and retaining the steel in the proper position as per the drawing throughout the concreting process is very, very important. I think with this now we can take few questions. So if there are any questions, I would like to go through the questions and then try to answer those questions. The first question is coming from Mr. Rohit Venkat. He has asked, can coupler be placed at joints like beam column joint, etc., to join the bars? Uh, I haven't come across any, uh, construction where people have used couplers in the beam, because, the moment you use a coupler in the beam, you are reducing the cover to the main reinforcement. So I won't recommend that, but in columns it is very frequently used and you should use that, because anyway column cover is always more than the beam cover. So you get more play in that. Then second question is, what is the percentage of scraps? It is very difficult to say, but you can expect anywhere between 2 to 4% scrap can be generated in the construction work. Then RCC consultant don't allow plastic cover blocks, but you are telling to use plastic cover blocks. What they tell now is use GRC cover block. Yeah, you are absolutely right. I have shown you those plastic cover blocks as just one of the variety available in the market. Few years back that was being used, but today still few construction sites are using plastic cover blocks. But there is the issue of bond, because plastic doesn't get bonded properly with the concrete. But whereas these concrete blocks or GRC blocks, they have a proper bonding with concrete, and from durability point of view that is recommended. Then what is the next question, sir? I want this seminar PPT for the presentation. I don't know whether this presentation can be shared. Perhaps the Tiscon management has to take a call on that. I can't guarantee you that. I hope if you had recorded this on your mobile, that would be better. That would have been a better suggestion from my end, that you should record the presentation when it is happening. Okay. Then the next question is, any alternative to steel as a reinforcement? Some R&D is happening, some research is happening. Some time back, I had come across a research paper where people had tried to use bamboo as a reinforcement material. But then, of course, it is very difficult to replace the steel. Some polymer steel also was, being, used for research purposes. But I don't think, commercially anybody has still, come with that kind of thing, because totally corrosion free steel, because corrosion free reinforcement, that is what this polymer based steel which was supposed to be giving that kind of advantage. But I am not sure whether it will be really coming in a big way. Okay, the next question is, which grade of steel should be used? That steel grade we have already discussed. There are 3 grades of the steel. So depending upon your loading condition and depending upon the durability which you are looking after, your structural consultant is the right person. He will decide which grade of steel is required for what kind of structure which is under consideration. Then why rebar test is required? What is the significance? Yeah, rebar has to be tested for its performance, because any product when you use, there is a BIS specification for that. If it doesn't meet the BIS specification, means it will not meet its end results. So that is number one. And significance of this is very simple. Without testing, if you use the material, it is not going to give you the desired results. There are many steel plants where they They use the scrap and manufacture the steel. That is known as what, recycled, steel, or what, I don't know what is the typical name. But that kind of steel may not be meeting the BIS requirement. So I don't recommend that such material which is not conforming to the BIS specification. I will not recommend that to be used. Why rebend test is required? What is significant? The rebend test is required because we said the steel should be bendable and it should not fail bend test, because you don't put straight bars. Normally the bars at the ends are bent to have the proper uh, hold in the concrete. So the significance is that uh, before the steel bars are used at the side, they are tested for this bending, and it should not crack during the bending, and it should not fail in a brittle manner. So that is why it is done. Then you showed column reinforcement joining with couplers. Then what about lap length 40D? No, you don't have to worry about the lap length. It is a perfect joint wherein you don't have to worry about the lap length. We are avoiding the laps, and it has been proven beyond the doubt that these couplers, they transfer the load, in fact, in a much better way when compared to the laps which we provide. So nothing to worry on that front. Then the next question is, can couplers be used for slab reinforcement? As I mentioned, for slab, the couplers will reduce the cover to the reinforcement, and that is not recommended. I will not recommend that. For columns, I will strongly recommend that. Good pictures of actual construction site. Okay, plastic cover blocks not good anymore. You are right. We must go with factory made concrete cover block. This is what Mr. Hemant Vadaikar is saying. Yes, you are absolutely right. How can you avoid corrosion of reinforcement in case if the procurement is done earlier in the construction site? As I mentioned, this is Vadiraj Rao and NR Rao. They are asking this question. We have to protect the steel from corrosion by, I mentioned how to store. So you have to, number one, uh, cover it with plastic sheets so that the moisture and the atmospheric humidity is not going to cause the corrosion. That is number one. And if still some corrosion happens, then the age old practice is, people put cement water slurry on the steel bars and then use it. But there are of course some corrosion resistant paints also which are available in the market these days, which are very frequently used for high durability. Then there is one Mr. Binay Tripathi. How does the negative bending moment works? Can I use cover blocks? How does the negative bending moment works? I have not understood this question. The negative moment, bending moment will be there at the junctions. Wherever you have the fixed end supports, you will have this negative bending moment. How it works, I have not understood the question. Can I use cover block in column and beams? Deepesh Saxena. Which kind of cover block you are talking about? I don't know. But you have to use cover block because you have to provide cover to the steel both in columns and beams. Then Mr. Yogesh Kalmarkar is asking me, are there any couplers without threading? I want to prepare the cage of the side and connect on site using couplers. I don't think, if you don't put the threads in the coupler, how the bars, will transfer the load. You have to have the threads. Without that, it is not possible. And Mr. Damodar Sahu is saying, can we use PVC cover block? PVC, plastic, they all have issue of bond with the concrete. I would prefer, concrete blocks. Nirav Patel is asking, what is the diameter of the couplers, whether it will affect the clear cover criteria? We should go. Yeah, the couplers thickness, the body thickness is around 3 to 4 mm. To that extent, the cover will be reduced. But, if you put the lap length, in that case, what will happen? if it's a 20 dia bar, then you will be reducing 20 cover by lapping it together. So it is better to losing 3 is a better situation than losing 20 So that is why couplers are very commonly used. Then Hemant Odalkar is asking, we should go with stainless steel reinforcement which has lower life cycle cost for the structure, but it is very expensive. Some structures have been tried. They have tried some few sites have tried this just as an R&D matter. Commercially it's not viable. If you have a lot of money and you don't care for the expenses, I don't mind you going for stainless steel structure, stainless steel reinforcement bar. Okay, Tej Shah, what he is asking? Uh, what he is asking? Basalt bars are used in some countries, though its cost is 160 rupees a kg. So very costly. Have you come across this in India? No, I have heard about these basalt bars. Absolutely, they will give you 100% durability because no corrosion is involved into that. But I haven't come across this in India. Okay, can we use PVC cover blocks? No, I already answered. That is Damodar. Then Suryakanta Mishra, how to know steel quality inside? Uh, you don't have to worry about the steel quality inside if you purchase the material from the standard manufacturers like Tiscon or equivalent. You don't have to worry about that. If you purchase the material from uh, recycled factories where they use scrap material and then reproduce the steel bars, then you will have all kinds of problems. So you should go to the standard manufacturers like Tiscon or equivalent, then you don't have to worry about the quality of the steel. Okay, then there is Charampreet Kaur. Charampreet Kaur wants to know, can you please tell us the thumb rule for deciding the quantity of steel for 1 cubic meter volume of concrete? Yeah, thumb rule says that for normal residential buildings, roughly 70 to 80 kg per cubic meter steel would be consumed. If it is a industrial building, you will perhaps end up using 100 110 kg per cubic meter. And if you are going for a multi-story building like towers, the towers could consume even 140 150 kg per cubic meter. Then the Tejas Hotele, where we should provide lapping of steel in column and beams. At the lap should come preferably at zero bending moment. The place where there is zero bending moment, you can provide the laps. Can you tell more about the welding of the bars? Doesn't the steel strength reduce if we weld the bar? Yes, steel strength gets reduced because of the welding of the bars. But in certain situations, it is unavoidable. Under such situation, you can compensate that by providing higher diameter bar, and you can still take care of the loads which are going to come on that. Okay, then Rahul Jaiswal is asking, any suggestions for what to do with extra length rebar left after reinforcement and construction? Can you extra length of the bar which is left after the construction, it has to go as a scrap. Where you can use it, this cannot be normally used in construction because the small length of the bars will invite two laps at both ends. So not recommended. It has to go as a scrap. Sayyid Mukhtiar is asking, can you brief about lapping zones in columns and beams? What do you mean by lapping zones? Actually, I have not understood. So I'm going to the next question. Ramakrishna Yemul, he wants to know whether couplers is IS recommended. Yes, couplers are IS recommended. There is no issue on that. Binay Tripathi, what is the negative bending moment in slab? Oh my God, this is a very basic question. you will you will only you have to refer to some book on strength of materials and read that. I can't explain what is bending moment on this platform. All civil engineering graduates, they are supposed to know this. Can we, Vasant Kumar wants to know, can we lap steel bars in bottom of the beam, sir? Okay. Yeah, you can do that. If there is a huge length of the beam, what you can do? You have to do that. You can do that. Why are companies promoting Fe 550 and Fe 600 steel? What are the advantages? See, since this Fe 550 and Fe 600 steel, the basic purpose of this steel is to reduce the steel consumption. This brings the economy. That is the only reason. If you use material with less strength, the consumption per cubic meter will go up. As simple as that. And today, in today's era, we have to optimize the cost. That is very important. So that is why people are recommending to go for that. But when you use these high strength bars, you have to also worry about the deflections. It is normally these high strength bars, are having tendency to give more deflections in the concrete structures. So one has to be careful, and during the design stage, one has to see that the deflections are within the limit when you use these high strength bars. Okay, I think I have taken many questions. How many questions? There are so many questions. My God, with primary or secondary quality steel should be used? Ramakrishna Yamur is again asking whether primary quality. Naturally, I will go for primary quality. If I am looking for the durability of the structure, it is always the primary quality. Srinivas Rao is asking what is the impact of holidays joint in durability joint. Oh, I haven't come across this holiday joint anywhere till date, so difficult for me to answer that. Then Prashant is asking, is there any reference or guidelines to use the electrical pipeline in slab, beam and columns? Electrical pipeline for what? I mean, for electrification work, anyways, we use pipelines, pipes in the slab beams, and I don't think there is any specific guideline for that. You have to see that these steel pipelines, they should follow the uh, criteria for providing the cover. You cannot allow it to touch the steel shuttering. It also should have the proper cover like steel bars. That is what is my practical solution for that. And what is the standard deviation and coefficient of variation for various grades of the steel? Mr. Khan Sher has asked that. Sher Khan, you have to talk to the manufacturers. They will provide you these figures. I am not having those figures right away with me now. Okay. Tej Shah, he has just put 2 question marks. I don't know. Perhaps he is confused. He doesn't know what he is going to ask. There are only 2 question marks. Vidyut Day, how can we improve fixing of reinforcement? Fixing of reinforcement can be improved by, uh, following the standard procedure. Use the standard gauge binding wire, and it has to be there is a particular way. These steel fitters, these experienced fitters, they exactly know how to twist the binding wire around the bar, so that it is permanently held together. So it is a bit practical thing on the site. If you go, an experienced fitter can perhaps give a very good demo about that. Whether Mr. Somnath is asking whether the use of corrosion resisting cement prevents corrosion of steel. Can we provide? Acha, oh, this is an interesting question. Corrosion resistant cement, actually there is nothing like corrosion resistant cement. It is a more of a marketing word that has been coined by a few cement companies. Actually, this corrosion resistant cement is nothing but Portland pozzolana cement. This fly ash, adds to the what can I say? It makes concrete more denser, because the secondary hydration will reduce the permeability and the voids in the concrete, and thereby the ingress of the moisture inside the concrete gets restricted, and thereby the steel, gets protected from the corrosion. So that is there is an indirect, benefit of Portland pozzolana cement in preventing corrosion. There is no direct correlation, but yes, some cement companies I know, I will not name them here, they call their cement corrosion resisting cement, but that is actually nothing but Portland pozzolana cement. Okay, now since we are running out of the time, it's already now we are touching 8. Last 2-3 questions I am going to read and try to answer if I know the answer. What is the minimum gauge of the binding wire? I'm sorry, I'm not able to recollect that, because I have left construction site work some 25-27 years back. I don't remember that. Maybe you can refer to the IS codes and find out that. Last 2 questions. Pushkar Patel wants to know, can we weld the bars instead of couplers? No, I will not recommend welding of the bars, because welding reduces the strength, and couplers can guarantee you the efficiency of the joint. But welding, in a particular say column, if there are some say 40-50 bars, welding each bar efficiently, it is very difficult to control the quality and the efficiency of the welding. So welding can be a risky solution, but couplers is 100% foolproof solution. I would recommend that. Now this is the last question I am taking from Charanpreet Kaur. He wants to know, can we provide the additional reinforcement for reducing the bending and shear force? Is there any IS specification for that? See, additional reinforcement is not going to help you, because it is always preferred that in the design we provide under reinforced section is always preferred than over reinforced section, because over reinforced section there is a sudden failure. So we never try to put more steel reinforcement for increasing the efficiency of the structure. In fact, under reinforced structures are preferred, because you get beforehand alarming warnings by cracks which appear in the structure because of the loading or whatever thing. So it is always preferred that we should have under reinforced section. Thank you very much, gentlemen. And I also wish to thank Tata Tiscon for getting me engaged with you. Without Tata Tiscon, I don't think I would have been able to connect myself with you and share my experience with you. Indeed, I am grateful to Tiscon, and I'm sure Tiscon will again call me to share my experience with you on some other topic, maybe in the near future. I'm looking forward for that opportunity. Thank you very much. कैसा रहा? क्या